Now we're going to take a look at conditional probability. So suppose we have two events, A and B, in some equally likely sample space, and we'll call that sample space S. Now look, an equally likely sample space is just some kind of an experiment that you perform and every element in it is equally likely to occur. Like if you toss a die once, the sample space would be 1, 2, 3, 4, 5, 6, right? If you look at the number on the top face. They're all equally likely. Now just pick two events out of that, like getting a 1 or getting an odd number, all right? So those are going to be two events in that equally likely sample space. Now here's what we know from our last section. In our last section, what we said was this, that the probability of some event, as long as the sample space is equally likely, was the frequency divided by the number. Now what I'm going to do here is this. I'm going to say the frequency is the number of elements that you count in A, and N, that's the number of elements in the sample space. But let's do an example so we're clear with the notation. We don't want to go any further if we're not sure about the notation. If you already got it, speed it up a little bit. But you might have something like this. Here is an example. Okay, suppose you toss a die, right, a single die one time, toss a die once, and look at the number on the top face. Here's the sample space. 1, 2, 3, 4, 5, 6. Now, here's some event. Suppose the event A, we're going to call the event A, getting a 1 or a 2. Right? So if a 1 or a 2 comes up, then A occurs. So what is the probability of A? Well, according to what we did before, it's the frequency divided by the number of possibilities. Now the frequency, that's just going to be how many numbers are in here, right? How often can that come up? Well, that's going to be the probability of, not probability, that's going to be the number of elements in set A divided by the number of elements in the sample space, right? The frequency is that number, and N is this number. In this case, the number of elements in A, right? How many elements down here? 2. How many elements in the sample space? 6. All right, so that's what we mean by our notation. So our notation tells us that the probability of some event A is the number of elements in A divided by the number of elements in the sample space. Now, what's the probability of B? Well, likewise, it's going to be the number of elements in that event divided by the number of elements in the sample space. And then we're going to look at this one. What's the probability of A? Now, that little thing right there, I'll do it at the top. It's like an upside down U. Not quite, but it's kind of like an upside down U. That is a mathematical symbol for the word and. This one here is or. And this is actually an intersection. And this is a union. If you've had a little set theory, you might remember that. All right, so when you see this, it means and. So down here, what's the probability that A and B both occur? Well, that's going to be the number of elements in A and B divided by the number of elements in S. Right? So it's the probability of some event that we're talking about is this. The probability of an event is equal to the number of elements in the event, N for the number of elements in the event divided by the number of elements in the sample space. So just so we're clear on this, what if we had this? What if A is the event getting a 1 or a 2, and B is the event, okay, B is the event getting a 6. Okay, so what is the probability of A and B? Right, you toss a die once. What's the probability that both A and B occur? Well, according to our notation, it's going to be the number of elements in A intersect B, A and B, divided by the number of elements in S. So how many elements do we have in A and B? Now, A and B is going to be what? This one and this one here. So I see 3 elements in there. Right? You got a 1, 2, or a 6. Number of elements in the sample space, I am seeing 6. So this probability is 3/6, or if you like, 1/2. All right, now conditional probability is this. What we want to do is we want to find the probability that some event A occurs given that some other event B has already occurred. Here's an example. So we might be asked this. You toss a die once, all right, and A is going to be the event getting a 1 or a 2. So if a 1 or a 2 comes up, A occurs. B is the event, an even number, right? So you toss a die, B is going to be the event, an even number. So if what, a 2, 4, or 6 comes up, B occurs. Now, what we want to know is, say, what is the probability that A occurs given that B occurs? So ask yourself this. What's the probability that you get a 1 or a 2 given that you already know that you've got an even number, right? So maybe somebody tosses a die and hides it. So you don't know what they have. But they do tell you this. An even number came up. Now, what's the probability of a 1 or a 2? Well, it's not out of 6 anymore because you know it's an even number. So there's only 3 possibilities, right? You got a 2, 4, or a 6. That's kind of what we're talking about here. So here's our formula coming up. So if A and B are events, so just imagine 2 events, such that we have to make this condition. The probability of B is not 0. You don't want to say something like this. You toss a die once. What's the probability of getting a 1 or a 2 given that a 7 came up? Well, you can't get a 7, right? So the probability of what happens can't be 0. Something has to happen. All right, so if A and B are 2 events such that the probability is not 0, right? Something has to happen. Then the conditional probability of A given B is this. Here's how we write this. The probability of A given B. All right, so that vertical line there, that is the word given. So the probability that A occurs, given that B already occurred. You know that B occurs. Now what's the probability that A shows up? Well, here's what this is. This is exactly the probability of, you take the and, the intersection, that both of them occur, divided by the probability that B occurs. So what goes on the top? The top is the intersection of these two. And what goes on the bottom? The one that already occurs. Now, because you just might like to see this, don't worry about it. If you don't quite get what I'm doing, that's fine. I'm just going to derive this because it's a math class and math people like to derive things. So I'm going to show you where this comes from. Now, if you're not really that interested, just speed it up and you'll go on to the next second. But if you're curious about it, here's where it comes from. All right, if we take this, all right, the probability of A given B is equal to, all right, now I could write this, say, as the probability of A and B over the probability of B. But what's the top? All right, the top is this. I'm looking at this. What's this one right here? Well, that's this. This is the probability of A and B over, I'm sorry, not the probability. This is the number of elements in A and B divided by the number of elements in S, right? How do you get the probability? Like, how do I get this probability? I take the number of elements in that event divided by the number of elements in the sample space. Likewise, for the bottom denominator, how do I get this? It's the number of elements in B divided by the number of elements in the sample space. Now, look, these are just all numbers. I got a number divided by a number. All divided by a number divided by a number. This is just a complex fraction, right? One fraction divided by another. So I know what to do here. I invert and multiply. So I get the number in A and B divided by the number of elements in S. Okay, it's this one times, invert that. Invert, right? Just flip it over. Times the number of elements in S over the number of elements in B. And then you can see what's going to happen here. The number of elements in S cancel, and you are left with the number of elements in A and B over the number of elements in B. Now what we just developed was this one here. The probability that A occurs given that B has already occurred is this fraction. It's the probability of A and B both occurring, divided by the probability of B. All right, that's conditional probability. Now solve, if I can spell it here, solve for the probability of A and B. Solve for the probability that both of these events happen. All right, well, we can do that. This is just a fraction, and when I solve an equation involving a fraction, I get the LCD, kind of overdoing it here maybe, and then I just multiply both sides by the LCD. So it looks like this, doing every step. What I'll have is this. The probability, okay, I'm going to multiply both sides by this. So I'm going to get the probability of A and the A given B times the probability of B, right? I'm just multiplying by this. So take this side, multiply it by probability of B. Now multiply this side by the probability of B. This becomes the probability of A and B divided by the probability of B times probability of B. All right, so all I've done is this. I started up here with our definition of conditional probability, and I multiplied both sides by B. I put dot P of B here, dot P of B here. Now what happens? On the left side, really nothing happens. We have this. The probability of A given B times the probability of B is equal to, but on the right side, those cancel. And we're left with the probability of A and B. Now I'm just going to turn it around and write this. What's the probability that A and B occur? Well, probability that A and B both occur is the probability that's going to be this right here. I'm just turning this equation around. The probability of A given B times the probability of B. Here's an example. What if we know this? The probability that A itself occurs is maybe like 0.3. The probability that B occurs by itself is, I'm just making these numbers up, 0.6. And then I know this, that the probability that A occurs, given that B has already occurred, right, now given that B has occurred already, suppose this is equal to 0.4. Right, so there's a 30% chance that A will occur in some experiment. There's a 60% chance that B will occur. But there's a 40% chance that A will occur given that B has already occurred. So if B already happens, then there's now a 40% chance that A will happen. So what is the probability that both A and B happen? Right, so 30% chance for A, 60% chance for B, but what about both of them happening? All right, probably that both of them happen. Well, we've got a formula down here, right? I'm going to use this formula right here. I'll write the formula, the probability of A given B, dot, the probability of B. Now, I have these probabilities. The probability of A given B, that is 0.4. The probability of B is 0.6. So what do we get here? We get 0.24. Here's an example. A driver is selected at random from the general population. We're going to take two events. Let A be the event the driver is under 25. All right, so you're just going to randomly select some driver out of the general population of all drivers. Now, A is going to be the event that the driver is under 25. B is going to be the event that the driver has received a speeding ticket. Okay, so A under 25, B received a speeding ticket. Now, a few parts. First of all, part A. Translate this into just mathematical symbols. The probability that the driver has received a speeding ticket and is under 25. All right, so when I read these, I look for these ands, these conjunctions here. So how about this? I want to translate this to the probability of something in terms of A's and B's. So can you do it? Pause it, write something, then come back, we'll do it together. So the probability, I got that, the probability the driver has received a speeding ticket, that's B, and right here, and is under 25 is that one. So we could write B and A, or if you like, it's the same as this, under 25 and received a speeding ticket. Right? Either one's good. part B of this problem. How about this? Can you write the probability? I don't want to mess that up. What is, all right, we'll start. Write this. What's the probability that a driver who is under 25, all right, so that's known. Write the probability in A's and B's that a driver who's under 25 has received a speeding ticket. All right, so here's what we know. The driver is under 25. What's the probability that that driver has received a speeding ticket? Okay, pause the video, try it. We'll do it together when you're done. All right, so here's what we do know. The probability that the driver who is under 25, all right, that's given. The driver is under 25, so I know I can write this. Under 25, that's A, right? That's the probability of that. That's A. The event driver's under 25. And what is the driver has received a speeding ticket? That's a B. All right, that's what I'm going to write for this, and I can read it. What's the probability that B occurs given that A has already occurred? So what's the probability the driver has received a speeding ticket given that the driver is under 25? Now in part C, it says the probability of a driver who has received a speeding ticket. All right, now I think that's what's given. That's the way I'm reading it. The driver has already received a speeding ticket. What's the probability that driver is, oh, be careful here, 25 or older, right? Not 25 or younger, but 25 or older. Now look at A. A is the driver is under 25. This is what a driver is older than 25. Now I'm going to write that like this. I think that's the opposite of A. So I'm going to write A prime, and that's going to be the driver is older than 25. Older or equal to. Right, it's the opposite. What is A? A is under 25. So the opposite is going to be older than 25 or even equal to 25. All right, so here's what we're looking for. We're looking for the probability of what? That the driver is not under 25, is what? 25 or older. So what's the probability that the driver is 25 or older given what? That driver has already received a speeding ticket. So I'm going to put a B here, and I'm going to put an A prime here. Now, right, some people use this notation, A complement. It's the opposite. All right, so this says, what's the probability of being 25 or older given that you've already received a speeding ticket?